Okay, the fifth page is just a summary of all the properties that we sort of covered, and you might want to add that non-property to it. But the last and final page is just a couple quick examples where we're going to do some integrals. So let's do them using our fancy property. So we want to integrate from -5 to 0 of 3 times f of x, not f of x. So what that's really doing is essentially that 3 is just making everything, all these little rectangles that build this thing, it's going to make this triangle just like 3 times bigger. So the property essentially says this. If you want, take that 3 out. Just take that 3 out and just focus on the triangle slash shape at hand and just triple the result at the end. So this should just be 3 times 1/2 of base, which is 1, 2, 3, 4, 5, times the height, which is down 1, 2, 3, and it's down, so you better make that thing negative. So it's half of 3 times 5. So 3 times 3 is 9. 9 times 5 is 45. This should be -45 over 2. But basically, just find the area of the shape and just make it 3 times bigger at the end. The next question is just talking about going from 0 to 5. Or sorry, it's from 0 to -5. So what's unusual about that is the smaller number is on top. -5 is smaller than 0. And basically what the deal is you're integrating, but you're integrating, the way we phrase this is from right to left. You're going this way. So the big thing we talked about in that very, very first video is that delta x is always top number minus bottom number, -5 minus 0, over however many rectangles you want to use. But you can't use negative rectangles, so n is always positive. So this is a case where delta x is going to be negative. And delta x is just the base of the super skinny rectangles you're using. So that just basically means when you find this area, which is 1/2 of base 5 times height -3, the base is -2. That's it. So this is actually positive. This should be 15 divided by 2. It sounds weird, but this is basically an upside down backwards triangle. It's down, so its height is negative, and its base is also negative because the thing you're defining to be the base of these infinitely thin rectangles is always top number minus bottom number divided by however many rectangles you need. We're just not using rectangles because it already makes a triangle and we know how to do triangles. And there's no need to approximate it because we can do it exactly. So what other people like to do instead when they do this problem is they just say, I'm going to reverse the limits, put 0 on the top, -5 on the end, and just make the answer negative. So I'm going to flip it, and I'm going to go left to right like a normal person. There's my negative. 1/2 base, which is 5, times height, which is -3. Negative times negative still gets us positive, and we get 15/2. So take your pick. Either make the base of your shapes negative when you're going right to left, or just reverse the limits, throw a negative in front. That's what most people do, but you can just make the base negative, and that should be fine. The next one is telling you to integrate from 3 to 6, so that's basically all of this region. But f of x plus an extra 2. So what that's basically doing, if we use that other property that says, hey, we can split this up, we just want to find that area. So that we can do, it's just a triangle plus another triangle. So that's just 1 by 2, and that's just 2 by 4, except it's down, so it's negative. We are going left to right, 3 to 6, 3 smaller, 6 is bigger. So that should be half of 2 by 1 plus half of 2 by -4. So that's just 1, and that's just -4. So together, that first piece is just -3. We just have to figure out what that second integral is, and it just says 2. Well, 2 is just this function. And if we're going from negative 3, 4, 5, 6, or sorry, not from negative 3, from 3 to 6, you're basically just talking about a rectangle that's 3 long and 2 high. So 3 by 2 is 6, plus an extra 6, that's just 3. That's it. I don't know how to do this all together yet. We'll eventually learn. But if we split it up, 2 is just a horizontal line. And a horizontal line makes shapes we know. It makes a rectangle, so you can do it, and it's just fine. The other way to think about it is that plus 2 is really just shifting the function up 2, which basically just puts a big 2 by 3 rectangle underneath the shapes you're making, which is why the area gets an extra 6 bigger. Now the very, very last problem on here is pretty much the same question, except it says x instead of 2. And that maybe seems scarier because it's a letter and not a number. Well, we can split it again. This is the same little right side up triangle, upside down triangle. That guy's going to be 1. That guy's going to be negative 4, just like it was before. It's just like, how do you do x? Well, x just makes a big diagonal line. Y equals x is just that diagonal line, and you're just going from 3 to 6. So you're just finding that shape. I would probably just split it up into a square and a triangle. So this should be 3, 3. It should be, that second little integral should just be 3 times 3 for the square part, plus half of 3 times 3. So that's 9 plus 4.5, that's 13.5. Overall, this final answer should be negative 3 for the first little piece, and 13.5 for the second little piece. That's 10.5. Ta-da, you're done. And that's pretty much it. Talking properties of integrals, which basically are, you can split them if it's addition or subtraction. You can pull constants out. If the smaller number is on the bottom and the bigger number's on the top, you're basically going left to right. That means your bases are positive. If the bigger if those are reversed, well, you can reverse the limits and just throw a negative in front, and that's just making your bases negative. You're just pre-planning for the negative base. Constants can pop out. You can do them one at a time if it's addition, and you can also split it up into subsections where you just do that triangle and just add your 2 results together. So those are our big integration properties. There should be a homework that goes with it. Hint, 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 if you're going to do the last page, draw pictures. It tells you some info, but it doesn't actually draw the pictures for you. I recommend that you draw the pictures, but that's about it. So hopefully these videos help.